Hey pre-calc students, today we're talking about solving trigonometric equations. So the first one that we're going to start off with is a pretty simple one. Um, so yeah, let's just kind of get started. The simpler ones will use typically just one or two steps and maybe the unit circle. And then more difficult ones will use things like factoring um, and square roots and squared trig functions and stuff like that. So we'll kind of get to those in a little bit. We're going to start off simple though. We're going to start off with just sine of theta equals 1/2. And we're going to solve it in the interval negative pi over 2 to pi over 2. Okay, so sometimes you'll be asked for all the solutions, in which case there won't be an interval and you will have to index your solutions. Sometimes you'll just be asked for it in a particular interval. So you want to make sure you pay attention to that and what the interval is. Okay, so this one's pretty much just going to involve using the unit circle because sine of theta being 1/2 is one of the values of sine that we commonly find on the unit circle. So if you got your unit circle memorized and everything, great. If you don't, the place where sine of theta is 1/2 is when theta equals pi over 6. One way that you could find this particular value is you could you could take the inverse sine of both sides, plug that into a calculator, and it would tell you that it's pi over 6. Some calculators will give it to you as a decimal. Some will give it to you in exact form like this. Either way, we do want exact form. So pi over 6 is the form that we want, and knowing at least the first quadrant of the unit circle just memorized is a good idea to have. But at any rate, this gives us one value where sine is equal to 1/2. Now, sometimes there will only be one value. Sometimes there will be more than one value, depending on the interval that we're in. So in this particular one, we're asked for the interval negative pi over 2 to positive pi over 2. So that's from down here to here. So just this half of the unit circle here. And in this case, theta equals pi over 6 is the only place where sine of theta is equal to positive 1/2. Because down here, when theta is 11 pi over 6, or negative pi over 6, if we're thinking of it in terms of negative pi over 2 to pi over 2, then our value of sine would be negative since it's below the x-axis here. So all y values, all sine values are negative down here. So the only value for this one is theta equals pi over 6 in this interval. If I were asked for a different interval, though, let's say I was asked for the interval instead from 0 to pi. So if instead I was asked for the top half of the unit circle, then we would have this solution, but we would also have another solution. We'd have one right over here at 5 pi over 6. So we want to watch out for things like that. We would end up having two solutions in that case. And so then what we would do is we would just list them with a comma separating. So we'd go pi over 6 and 5 pi over 6. Okay, so that's how we do it if we're just looking for particular ones within an interval. All right, so there's one way or one example of solving a trig equation, a pretty simple one. So let's do one that's a little bit harder. Okay, so the one that's a little bit harder is going to be 3 tangent squared theta equals 1. Okay, so for this one, what I think I would do first is divide by 3 on both sides. So we get tangent squared equals 1/3. Oh, and I forgot to mention at the beginning of this problem, we want to solve this one, let's see, for the interval 0 to 2 pi. Forgot to mention that. So there, we want all values in the unit circle, basically, for 0 to 2 pi. All right. So now that we've gotten to tangent squared equals 1/3, I'm going to take the square root of both sides. So we get just tangent equals the square root of 1/3. And remember, when you square root a fraction, it's going to be the top square rooted over the bottom square rooted, because you can split it up like that. And it's also going to be plus or minus the square root of 1/3. So the square root of 1 is 1. The square root of 3, square root of 3. So we have plus or minus 1 over the square root of 3. And the rationalized way of writing this is if I were to multiply by the square root of 3 on the top and on the bottom, which would give me plus or minus root 3 over 3. Now this is important because this is the more easily recognized form in the unit circle of tangent. So anyway, you could leave it like that. It's technically not rationalized. If we switch it to be like this, it makes a little bit more sense when we go to the unit circle here, which we are going to do. So here we go. We want to find values in the unit circle from 0 to 2 pi that have a value of tangent being either positive root 3 over 3 or negative root 3 over 3. So one value of theta here that has positive root 3 over 3 for tangent is pi over 6. And remember, that's because for the coordinates here, we have root 3 over 2, 1/2. So if this is my, my x and my y coordinate, it corresponds to sine and cosine, cosine and sine. When I find tangent, remember tangent is sine over cosine, so it's really like y over x. So the y value over the x value is 1/2 over root 3 over 2. And then when you flip and multiply, you get 1 over root 3, which is root 3 over 3. So if you didn't have the tangent values of the unit circle memorized, that's one way that you can find them. If you don't have the tangent values memorized, then leaving it like that with 1 over root 3 is a step quicker. But if you do have them memorized, you likely have it memorized with the root 3 over 3 format. Anyway, long story short, pi over 6 is where it is, where tangent is positive root 3 over 3. Then there's another place on the unit circle from 0 to 2 pi where tangent is also positive root 3 over 3. And it's actually the place that's 180 degrees or pi radians away from pi over 6. So if I just add pi to this, we get 7 pi over 6. And that is another place where tangent is root 3 over 3. An easy way to think about this is that tangent is like slope. It's y over x, right? It's this, the rise over the run of this particular line. So if I were just to continue this line back, the next place that it hits the unit circle right here would be its corresponding spot pi radians away. Anyway, 7 pi over 6. Or if you have your unit circle memorized, again, you would know that tangent down here at 7 pi over 6 is root 3 over 3. Okay, so that's our two values where tangent is positive root 3 over 3. Now we need to know where tangent is negative root 3 over 3, since we had both options here. So the place where that happens, well, the first place anyway, is at 5 pi over 6. And for the same reason as we had with pi over 6 over here, the x value is negative root 3 over 2. The y value is positive 1/2. If I go y over x to get tangent, then we get negative 1 over root 3, which is negative root 3 over 3. Then, using the same logic, we can extend this. One of the ways you can think of it is, extending that line, the one with the same slope corresponding over here, is where theta is 11 pi over 6. Okay. Or you can also, again, think of it in terms of the unit circle, remembering that 11 pi over 6, your coordinates are root 3 over 2 and negative 1/2. So then for tangent, it would be negative root 3 over 3. Okay, so these are our 4 values of theta that will work in the interval 0 to 2 pi. So our values of theta that we would write out are, we have pi over 6, we have 5 pi over 6, we have 7 pi over 6, and we have 11 pi over 6. Okay, so that would be our complete answer. So that's our second example for solving trig equations. If you want other additional examples, I have a couple other videos posted on YouTube, one with solving a trig equation kind of like this one, but solving for all possible solutions. So instead of just within an interval, it's every single solution ever, and how we would index those. And then I have another example also posted about what you would do if you need to factor in order to solve your trig equation. So hopefully this was helpful. Feel free to send me an email or comment below if you have any questions. Have a good one.